Hello children. In this video, let us try to work out these problems given in exercise 2.2 of your polynomials chapter. Find the zeros of the following quadratic polynomials. So first, you should find zeros and verify the relationship between the zeros and the coefficients. Let's start with the first sum. So first, let's find the zeros of the sum. The zero of this polynomial is the value of x at which the polynomial itself becomes equal to 0. And remember, because it's a quadratic equation, we'll have two values of x. There are two roots, at most two roots in a quadratic equation. So let's start factorizing them for the purpose of solving. So for factorizing, we split the middle term such that the sum of the terms is equal to minus 2 and the product should be equal to minus 8. So let's find factors for minus 8. Minus 8 and 1, it does not add up to minus 2, so we cannot use these two numbers. Why not minus 4 and 2? Minus 4 multiplied by 2 is minus 8, yes. Minus 4 plus 2 is minus 2x, yes. So we will use these factors and rewrite the quadratic as x squared minus 4x plus 2x minus 8 is equal to 0. They are one and the same. We have just split the middle term. Now let us do the grouping of these two. X squared minus 4x is one group, 2x minus 8 is another. Take out the common factors from x squared minus 4x. It is x into x minus 4. So you are doing the factorization in such a way that if you multiply, you will get x squared minus 4x. And what about the second group? Once again, x minus 4 in the bracket. So plus 2 is your common factor. When you multiply, you get 2x minus 8 again. So all of this is equal to 0. So in these two terms, x minus 4 is common to both the terms. So x minus 4 into x plus 2 is equal to 0. So we have done the factorization. Now what are the zeros? Either x minus 4 is equal to 0 or x plus 2 is equal to 0 or both are equal to 0. So if x minus 4 is equal to 0, now let's add plus 4 to both sides of the equation. You get x is equal to 4. This is 1 0 of this quadratic equation, quadratic polynomial. And if you subtract minus 2 on both sides, you get x is equal to minus 2, which is your second 0. Now for the verification part. What should you verify? The relationship between these two roots and the coefficients. Now a general form of a quadratic is represented like this: ax squared plus bx plus c. This is equal to 0 where a is not equal to 0. What is the relationship? If you assume alpha and beta, any two random alpha beta numbers, their relationship to the coefficients is, if you add the roots of the equation alpha plus beta, you would be getting minus b by a, which is negative of coefficient of x by coefficient of x squared. And the second condition is, the relationship is alpha beta is equal to constant term by coefficient of x squared. So let's check whether these two roots 4 and minus 2 satisfy this relationship. So 4 plus minus 2, this is equal to 4 minus 2, 2, right? Yes, 2 is equal to minus of minus 2 by 1, which is b by a. This is your b by a, isn't it? So negative of minus 2 by 1 is 2. So this relationship is verified. It satisfies. And what about alpha into beta? 4 multiplied by minus 2 is equal to minus 8, which is nothing but your constant term by 1. 1 is your coefficient of x squared. So c by a. So both these relationships are verified. So your first sum is over. I hope you followed. Thank you.